Well, first of all, thank you for inviting me to your forum on waste management here in Reykjavik. And it's the first time I'm here in Iceland. But I come from southwest of Norway, near Stavanger. And I believe that this country was populated from our area, so to speak. So let's just say in the spirit of this meeting, we're family, I think. So I come from KVitebjo Energy, and I will explain you what we do. And then I will move on to approach the waste to energy as a business or as a technology. Now, first of all, KVitebjo Energy, we are engaged currently in 4 sites, 4 places. In Tromsø, I don't need to explain to you the geography, I suppose. That's the north of Norway, and we are also engaged in Fredrikstad. He just mentioned that. We're engaged in Elkem in Salten, and you know the company Elkem here in Iceland, I believe. And finally, we're engaged down in the Netherlands, in Steenwijk. So for both Tromsø and Fredrikstad, the business idea, the business model is thermal treatment of waste. And in the case of Tromsø, the plant produces hot water only. And the hot water is then distributed to the city of Tromsø. We think that shortly we will supply the city of Tromsø with some 150 GWh of energy, which is quite a lot. And then this energy then replace the use of electric power, electric energy. So that's to the benefit of, well, let's say it's the Kinder egg. It's you on one hand, you have a local treatment of the waste in the Tromsø, for the Tromsø region, and on the other hand, you supply heat at an affordable price to the community, and then you take off the stress on the power grid of Tromsø, because Tromsø is an expanding area, and they use every year there are people moving in, and they use all of them also use electricity. So this is have a system effect by lowering the burden of the electrical grid. In Fredrikstad, we also do thermal treatment of waste, but that's the picture here is rather different. We produce steam in Fredrikstad, and then this steam is again delivered to district heating to the city of Fredrikstad, but also the plant is located at an industrial site. So we deliver steam to the industry, and by doing that, we provide them with energy at a competitive prices. So which again supports the industry to stay competitive and to remain economically viable. And finally, we also generate power from the Fredrikstad plant. Generally, as we all know, in the winter time, the demand for district heating is higher. So in the winter time, from the Fredrikstad plant, we hardly produce any power because all the energy is delivered to the district heating network. But whereas in the summer, we admit more steam to the turbine generator, so we produce power in the summertime. And then the Steenwijk plant that use biomass, they don't use waste, they use biomass. And then it's a combined heat power plant, produce power to the grid in the Netherlands, but also it allows for business, for production of pallet spacers from waste wood. So again, recycling, a double effect, you may say, on recycling. So Again, you see that that waste to energy support business, support the establishing more business. So it's not only the treatment of waste, but it's also, you may say, an effect for the society, positive effect for the society. In Elkem Salten, we do reclaim heat from the fume. So that's a totally different aspect, but again, it's all renewable energy. Today, the fume from the aluminium production is going to the birds, and then all the heat is going from away into the atmosphere. But due to you may say the pricing of power in Norway, and also the improved regulatory measures of Norway, it's now it's a good business case now to install to make a big investment into steam-powered turbines. So the outcome of that is a capacity of 32 megawatts power, and this plant will go on stream next year. And our company, we're looking for more projects. Let us be clear about that. So now to add some more, let's say, flesh to the bone of thermal treatment of waste. This is our plant in Tromsø. You can see the waste going in. Maybe I can use some light here. Yes. The waste being introduced. There are a number of ways of doing this. This is the way we do it in Tromsø. And the resulting energy from the incineration is turned into fumes, and it's the fume that carry the energy. So the energy conversion is by the hot fume is then being cooled off in the boiler tubes, and then the fume is going into what we call a quench. There we have, that's where the fume treatment starts. The flue gas treatment starts here, or by introducing humidity and introducing lime to abate the sour components of the gases. And then finally you have the final stages. Here is the filters, and then here there's the key one of the key components to any plant. That's the fan. So in any plant, that's the biggest consumer of power. This one here. So the whole this fan sucks air all the way from the chamber through all this piping, and after the filter, the flue gas is clean, and then going through the fan, and then passing by a measurement station for analysis, flue gas analysis, because all the fumes are constantly monitored. And then to the stack, what we call it. And on the other hand, the energy being absorbed by the boiler ends up in Tromsø as hot water, and then to be distributed to the district heating network. Typically, I think around about 90 degrees, 95 degrees maybe. Depends on the time of year, actually. When it comes to the emissions, I already told you, there's the fumes. There are also emissions to in the form of bottom ash and fly ash taken up in that filter. The bottom ash is considered non-hazardous, and typically the amount is about 20%, depends on what me and you throw in our waste bins, basically. But normally, in a normal case, between 15 and 20% in tons. But as I say here, the volume reduction is about 90%. And for the fly ash, it's about 40 kilograms per ton of waste. And the current situation in Tromsø, as everywhere else, is that the fly ash is hazardous waste. But I have got some good news for you. There are some research developments going on for fly ash, back home in Norway that to me points towards treatment plants for fly ash, because the current situation for fly ash is that it's been transported to landfill sites, and then it's being mixed with acids from the industry, and then after this treatment it's deposited in the landfill. But this is the situation in Norway, and it causes, of course, logistics, and it's as a business we always look for more recovery, and we see now that I think in a couple of years we will see plants coming for treatment of the fly ash, and these plants will be an integral part of the waste to energy plant. So I see that coming, and if there is a plant built in Iceland, you should go for that. I would say it's within reach. So all in all, then a plant like this will not produce hazardous waste, which is good news. And the product of that treatment of the fly ash can be sold in the marketplace as salts, as heavy metals like zinc, and as maybe as a contributor to the cement industry. My next slide was already used by Ella, so I won't comment too much about that. I'll just repeat her message. A lot of effort is going into cleaning flue gas cleaning systems, in investments and in operational costs. And all of this is thanks to Brussels. We all welcome the legislation from Brussels, which we all have to adhere to. And now there's a new round being completed, a new revision of the limits. The limits go down, and we welcome that as a business, because this is, of course, the core, well, let's say, milestone or the core factor of our business. We need to be clean, otherwise we'll be out of business. If our operations are not clean, we have no legitimate reason to stay in business. That's what. So we welcome that. What you see down here is a control room from a rather big plant. So none of our plants have a control room like that. But I think that's from Copenhagen. But this is the reality in a control room. You supervise the process going on. And any alerts for emissions or other things will be notified by the control room, and actions will be taken. Okay, maybe I'm using too much time here. Norway, family. We're a long stretched country, and the waste management of Norway, there's no parallelity. You have systems for the districts, and you have systems for the cities. So they vary all the time. I guess the same goes for Iceland. With respect to our business, 17 plants, 1.7 million tons. Of course, that's a nice average of 100,000 tons of each plant, but that's not the case. The smallest plant of Norway, around about here, they process some 10,000 tons per year, and then the biggest plant just south of Oslo process or treat some 360,000 tons per year, or let's say 1,000 tons per day. But most of the plants, they're here, between 50 and 100 tons per year. And another thing about Norway is that the technologies involved are many, because of the wide range of capacity. We have all the technology providers there, Vølund, as you may know of, Energos of Norway, and Hitachi, etc. And another thing for the plant owners of Norway, we are private up in Tromsø, but the general rule, I guess, is that the owners are public, either owned by the municipalities or owned by the regional power companies. It varies. But I think the trend, both in Norway and also in Europe, Belgium, Netherlands, UK, is that the private ownership. That's the general trend. And we all, of course, have to comply with the strict rules of emissions and the overall environmental footprint. Okay. Now back to my area. This is in the southwest of Norway. We have an integrated waste management system approach. Well, this is not my figure, but they claim to have 65%. Then again, referring to the accuracy of the calculation method, I just raised the question. I don't know if it's true. But we have some 2 stations for bulky waste. This area, by the way, from here down to here, it's about let's say 80 kilometers, around about that maximum. And then the collection system. We have a collection system for residual waste, cardboard and paper, and food and garden waste. Typically, and this is in an urban area. You have perhaps you have that here in Iceland too. We have in my area there are between 3,000 and 4,000 like this now. So it's become the done thing. So in the new residential areas, in our area, you don't see any plastic containers anymore. It's all this 5 cubic meter of containers below ground. So this is the collection. You have a sorting plant that's just gone into operation, and out of that, the plastic and paper for recycling, and residual waste to incineration. So on this site, I was here for nearly 15 years as a managing director for that plant. So I saw 2 plants being built in my time. So the big change taking place now is that the waste no longer has been driven to the plant. The household waste it's been driven to this plant, and after sorting, it's been transported by a conveyor about 300 meters long into the plant. And but also on this site, you have a recycling station, and you have a private sorting plant. So it's a very compact and nice area. So if you ever go to the area, go and visit. Now, I won't use much time on this. It's just to exemplify our position in the hierarchy. And I just come back from a 6-month stay in Brussels, and where Ella was my boss, and I discovered the term upcycling. That's a good word, upcycling. Which means, of course, that waste that is, let's say, been disposed of, if it's upcycled, then is redirected to recovery. Or if the waste is available, is then used for recycling, and it's upcycled from waste to energy to recycling, etc. So of course it's the same old story, but in a different manner, let's say. And I think this is an important message. This is an important message. If Iceland ever want to go to follow the family in Norway, Sweden, and Denmark and Finland, and introduce a landfill ban, there's no way forward, in my mind, without waste to energy. You can't make it. That's the experience from all the countries that have done it. It's feasible with waste to energy. All right, I think it's my final slide. Iceland, you're looking towards, you're on a crossroads. You are discussing what to do. And Iceland have to decide. All I can say, the critical building blocks to establish a waste-to-energy plant are these. You need to attract investors. You need a long-term waste supply. And of course, in a big European city, life is easier. In Brussels, the prospective plant owner discuss with the city of Brussels. But here in Iceland, you have to discuss with many entities. So things are more complicated in Iceland, I think, than in a big European city. You need a stable energy offtake. So you need to be located next to your energy consumer, whatever that be. I know from the discussions here I've had during the last 24 hours, it's been pointed towards certain directions, but that's important because you need to have an energy recovery level that satisfied the Waste Frame Directive to achieve the R1 status. So you need to be located next to the energy consumer, energy off-taker, which again can cause some business for them, business for the local communities. So again, suitable location, that also goes for the overall environmental impact, neighbors, etc. Access to harbors, perhaps, for the residual products, etc., etc. Proven technology, I don't think it's... there's so much technology, proven technology out there now, all sizes, all capacities. There's no need to experiment. Keine experimenten, as the old Adenauer said in Germany, I think. So I would say proven technology. Low environmental impact, what does that mean? It means low emissions for the plant, but also it means for the logistics, for bringing in waste, bringing out residuals, should be have as low impact as possible. So that's important for a successful project. The operational skills, what we see back home and elsewhere in Europe, I think that if you build a plant, if the plant owner has operational skills, that plant will have the best performance and the lowest cost. And what we also see, if you have an unexperienced owner, the result is the opposite. Then you're in the hand of the consultants, and the practical things go very often wrong. So operational skills from the owners, very important. Financing package, important because these plants are expensive. So you need to have financial, the best financial, let's say, conditions, the less financial cost possible. The predictable residuals offtake. Of course, you need to get rid of your residuals. So you need long-term contracts or prospects for your residuals. And finally, long-term and supportive ownership, very important. You see that all the time. If you have supportive owners, the companies and plants that have supportive owners, they perform best. They're the best performers. If you have a passive owner, which is the opposite case, you never know what happens. Okay, so final slide. I think that goes to the policymakers. They have to make important decisions here in Iceland. Iceland must decide what to do. First, what is the capacity of waste to energy? What is the correct capacity? Sorry. Waste to energy capacity on Iceland. You have to decide. Should we do it here, or just, if no, export everything? That will leave nothing for no energy for off-takers in Iceland. Then everything goes to Europe, and then to the benefit of Europe, and also throws in an uncertainty, because the off-taker in Europe will the plant be open for all this waste all the time? At the moment, all plants in Europe are full. There are no available capacity in Europe at the moment. So if you decide to build on Iceland, you know what your future is. You guarantee the downstream. You're guaranteed the future. Then next, you have to the policymakers have to decide on suitable locations and to support the project, because very often we see that to establish projects you need support top down from the EPA, not downwards. And finally, you have to decide on ownership. Who's going to own this plant or these plants in private, public, or private-public? I think generally the owners have to contribute with skills, with finance, or other. That's the key factors. So when the policymakers have done this, then the project starts. You can't go wrong, can you? Yes. Thank you.
Thank you very much, Rune. Spurningar. Við höfum hérna örfáa mínútur. Tíminn reyndar aðeins komin lengra en við ætluðum, en þetta allt innan marka en þá. Engin sem ætlar að spyrja, nú hérna hérna maður sem hefur reynslu af því að gera þetta. Hún reka sorporkustöðvar í mörg ár.
Well, let me just conclude, Stefan, that as a company, we have my chairman in the podium here, and we're both committed to any project in Iceland. We're willing to engage if you want us to. And of course, we're humble. We understand that whoever's coming in has to be prepared for competition. But on a preparatory basis, introductory basis, we're here for you, and we can contribute. Okay. Yes.
If my name is Anders, and I'm also part of KVitebjo Energy. Rune, could you maybe say something about other type of waste that also are possibilities in these type of plants, hospital waste, and it's
Yes,
also possible to think
Yes.
other solutions for local small stream wastes.
Yes, I think Bjorn from Sorpa also explained about that briefly, but I didn't understand. Yeah, I'm okay. I didn't understand all of that, but I think you touched upon that. Of course, and also Ella, the hygienic task for the society, and to so in my country and the plant I've been running in Stavanger, we're a very important solution for the hospitals. The hospital waste, and all sorts. So the permits now that are running in Stavanger area allow all the waste from the low risk waste, all to be burnt in the plant. And of course there are many waste streams in the society that is hard, that is difficult to treat other than thermal treatment. Yes.
Thank you very much, Rune.
Yeah.